This is number 38 on page 118, and basically it tells us we have a 3 kilogram and a 5 kilogram mass, two masses, 3 and 5 kilograms. You can see the picture there, connected by a light string over a frictionless pulley. They want us to find the acceleration, the tension in the string, and the distance each moves in 1 second if it starts from rest. Again, the first thing you always have to do is you always have to do force diagrams. So we're going to do force diagrams, and or free body diagrams. We're going to do one for each object. So this is the 3 kilogram object. It has two forces on it. It has Ft up, and it has mg down, and we know mg is 30 newtons. This is the 5 kilogram mass, and it has Ft up, and mg down. Mg means mass times in kilograms times 10 meters per second squared. 5 kilograms times 10 meters per second squared is 50 newtons. These two tensions are similar. I mean, they're the same in ideal situations where we have a frictionless pulley and a light string, so we're going to consider them the same. And so the first thing we're going to do is find the acceleration. And to do that, we're going to use Newton's second law. So I think A actually asks for tension, but I always do acceleration first because it's easier. So we're going to do sum of the forces equals ma. That's on your equation sheet. So we're going to look at the orange one first. Down's negative, up is positive. So Ft minus 30 newtons equals 3 kilograms times A. Notice I have two unknowns there, so I'm going to have another equation. Also realize acceleration is up on this one, and acceleration, of course, is down on that one. So the next one, the blue one's going to be Ft minus 50 newtons equals 5 kilograms times negative A. Now, the easiest way to do this is subtract these two from each other. It's called elimination. So if I put a negative sign out here, which means I have to multiply through by a negative sign, and then this becomes negative, that becomes positive, and that becomes positive. So Ft minus Ft is 0. Negative 30 plus 50 is 20 newtons. 3 plus 5, remember negative A times 5 would be negative 5A, so 3, this is going to make it plus. 3 plus 5 is 15 kilograms times A. Divide both sides by 15, and you get A equal to 2.5, I do believe. Let me check my answer on that. Yeah, 2.5. Remember, when you check your answers in back of the book, since we're using 10 meters per second squared, you may not get exactly the same answer because they use 9.8. Okay, the B part, they want us to find the tension. So to find the tension, all I'm going to do is I'm going to substitute this back in an original equation. It doesn't matter which one, but if I substitute it back in this bottom equation, the one that has 50 newtons, I have to be sure it's the original with the negatives in it. So I'm just going to put it in this one. So that basically it's negative 30 equals 3 times 2.5. When you do that, you're going to get Ft is equal to 37.5 newtons. So Ft minus 30 equals 3 times positive 2.5. So 3 times 2.5 gives me a number, and then I add 30 to it because it's net minus 30, so I add it on both sides. That's how I get that. The C part, they want us to find how far it moves. How far does it move in 1 second? Well, that's kind of simple because we have the acceleration already, and we know x equals, x naught and v naught are 0 because it starts from rest and it starts at 0, so it's just the second equation on your equation sheet. Looks like that. So x equals 1/2 times 2.5 meters per second squared times 1 second. X, if you do the math, is 1.25 meters. That's it. That's how you do number 38.